Okay, so let's look at this question. Using the method of joints, so we need to take it joint by joint to determine the force in each member of the truss shown. So that you can see the truss shown here. This is homework number 9. You can see it, there is a hinge here, point A, and there is a ruler at point C, and you can see that there is a force 15 kilonewton, and there is a force down here 49.5 kilonewton. So he wants to know the method of joint, determine the force in each member of the truss shown, state whether each member is in tension or compression. So he needs to find out the force in each member, and he wants to know, is it compression or is it tension? And before we do anything, we have to find out the forces in this hinge and this ruler. Okay, so we will draw, and imagine, we should know 3.2, 2.4, 2.4, and 7 meters, because we want to find out the angles later on. So let's rearrange the figure. Remember, there was a hinge here at point A, so there is a reaction AX and there is a reaction AY. And there is also a ruler at point C, so there is a reaction upward in the y-axis. So I'm going to call this one C, because there is nothing in the x, so I'm going to call this one C, and it is in the y-axis because it's a ruler. I'll go back. It's a ruler. You can see that there is, points here. It's like it's moving. So ruler is only in the y-axis, and a hinge like that, it is AX, AY. Okay, so we're gonna put this. I'm gonna call this one O in the middle. So by doing this, let's find out first of all the first equation: summation of forces at x equal to 0. You can see here how many x-axis. AX is 1 and 15 is a second. There's nothing else in the x-axis. So summation of forces at x, this is the first equation, because we're going to apply the equilibrium. AX plus 15 equal to 0, which means that AX is equal to 15 and the minus, because if you take this 15 to the other side, it's minus 15. So AX is minus 15 kilonewton, which means that AX direction that I assumed is wrong. So I have to put AX the other side. So AX is 15 kilonewton, is going the other side. So, I could put AX any directions, but if it's negative, which means that our assumption is wrong, we have to go backward. Now, what is the next process? Summation of forces at y equal to 0. Now you can see here there is AY in the positive, 49.5 in the negative, and C in the positive. So summation of forces at y equal to 0, C plus AY, you can see it, C plus AY minus 49.5 equal to 0, which means C plus AY equal 49.5. Here we have two unknowns, and it's one equation, so we have to wait. We have to find the third equation, summation of moment. Which summation of moment we should take in order to solve this problem? The best is you should look at the point with too many reactions. Look at point A. There is AX, AY. Take this moment at point A. So if you make a nail at this point A, it's up. The reaction C is up. So this gonna move the whole thing this side. Remember, going counterclockwise, it is positive. This one, and you have to take the perpendicular distance between point A and C. So remember, what is the perpendicular distance? Let's go to, from here to here is 7, and 3.2 is 10.2. So at point A, C times 10.2. C times 10.2. Let's look for the other one. At this point, let's look at 49.5. if you make a nail at this, this will push the whole thing that way, which is a negative, because this is clockwise. This is gonna push it that way, clockwise. So what is the perpendicular distance between this force and point A? It's this, from here to here, perpendicular. This is A, perpendicular. What is this distance? We should go. This distance is 3.2. So, and it is negative minus 49.5 times 3.2. So, of course, minus 49.2, because he put it the other side, because it's negative, so he put it there, times 3.2. The last one, a moment at this point, this one will move it that way. It will pull it counterclockwise, and this is the perpendicular distance. Look at this. Okay? So the perpendicular distance is 2.4. 2.4. So 15 times 2.4. Now remember here, all of this, you have C. So you could find C. C would equal to 12 kilonewton. And since it's positive, and since we assume it's up, it's still gonna be up. So now, remember this equation? We found C here. You could put it here, you could find AY. So now, AY is positive, so our assumption that's going up is correct. So now, we have AX, we have AY, and we have C. So we find all the joints. We find the hinge reaction and we find the ruler reaction. So we found AX, AY, and we find CY. So now we want to find the angles, because now we want to do the joint method. So we want to find angle, since we're going to take joint A, and because here he wants the method of joints. So we'll take joint A. But we need to find out the angles. Either we find the angles or you find the slopes. It's completely up to you. So you could find the angle from here, or you could find the angle here. So let's call this one O, DO, DAO, with this angle. If you make tan inverse of this, or tan theta is equal this 2.4 over 3.2. So you can find the angle A. And the same thing for the angle at this location. Okay? So if you find the angle at this location, it's the same thing. Tan theta is equal this 2.4 over this 3.2. And same thing for the angle here. The angle here, tan theta here, it is this 2.4 over 7. Same thing here, tan theta here, it's 2.4 over 7. So 2.4 over 7, it's tan the theta, so theta is tan inverse of that, theta is tan inverse of that, so you could get the angle 36.869 and you could get angle 18.924. So now, let's take the first joint, joint A. Remember joint A, there is reaction here. There is AY, there is AX, and there is force AB, and there is force AD. Okay, so remember the 15 was negative, so it's going to be in the negative X. That's for the reaction AX. And remember we found AY 37.5 is going to be up. Either you take it like this from here, it's the same thing. It's going to go up here, and this is going to go negative, because 15, remember, it was negative. Now this is the force FAB, and remember we found the force FA, the angle with FAB, 36.689. Remember here? $36.869. And also, the other force, FAD, is 36.869. For joints, the only way to solve the reactions for joints is to find summation of forces at X and summation of forces at Y for joints. For the sections that we're going to see next, we could do moments. But for joints, very simple, very simple. Now, let's find summation of forces at X equal to 0. You can see here, if you're looking at X, FAB cosine 36.869 going positive. FAD cosine 36.869 going positive. Minus 15 equal to 0. And Fy, you can see FAB sine 36.869 positive. FAD sine 36.869 going negative because the sign is this way and this sign is that way, plus 37.5 kilonewton. So we could find the summation of forces at X and summation of forces at Y. So here he just took the cosine 36.869 as a common factor. You could do that because he just wants to simplify the equation, which is like, originally it was FAB cosine 36.869 plus FAD cosine 36.869. So he took this as a common factor. Minus 15 equal to 0. So he put 15 the other side, and now he could make this 115 divided by this to find out 18.749 kilonewton. So which means this plus this equal to this. That's equation number 1. Now summation of forces at the Y, remember it was sine and it was the 37.5. So you do the same thing. You take this one up there, it's a minus, divide by this, it will be minus 62.5. Now FAB minus FAD is equal to this. So now, you see this, you have this equation and this equation. If you add them together, FAD minus FAD, they will cancel out. So you'll have 2 FAB, this plus this, you could find FAB. Remember, FAB would be equal to negative 21.9 kilonewton. What is the meaning of negative? It means that our assumption, we assumed it here, we assumed that tension. Tension means you are pulling. So if FAB is pulling, if AD is pulling. If it's negative, which means that our assumption is wrong. It's not tension, it's compression. So you go here. FAB, we found it to be equal to minus 21.9 kilonewton, which means that our assumption initially as the tension is wrong. So the answer is FAB is equal to 21.9 kilonewton compression C. Now we could plug in this number. Don't plug in the C. Plug in the real number, that the one you got, minus 21.9. Don't plug in the positive. You put it here, minus 21.9. You just like make it plus because you take it the other side. Minus this and minus FAD equal to minus. So it's going to be FAD is equal 40.6 kilonewton. And since it is a plus, our assumption is tension. It's correct, tension. So now we find FAB, we find FAD. Now, let's take the other joint. Let's take joint D. Let's go to joint D. Let's go to joint D. Joint D, you can see that there is a force here, 15 kilonewton, and there is a force FDC. And remember, we have this angle. We have this angle, which is equivalent to this angle. And we have FDA. And remember, we have also this angle, because this angle is known. And we have FDB. And FDB is, we're going to assume them all tension. Okay? So we're going to assume it tension, tension, tension. And FD and 15 kilonewton is going to the right. So this is at joint D, FDC. Remember, it's 18.924 because of it is the values. and this is 36.869 because the angle was here, so the angle is here, angle is there because the angle was there, and FDB is going pulling, and 50 kilonewton. These are the only forces. And again, by joint method, we only do summation of forces of X equal to 0 and summation of forces of Y equal to 0. Okay? We don't do summation moment for joint. So here, what is the best one is to find summation of force at X equal to 0. FDC cosine 18.924 minus FDA cosine 36.869 plus 15. 15 plus, this is going to go cosine plus, and this is going to go cosine negative. Remember, it's negative, cosine, positive, cosine, 15 equal to 0. Now you could play with the things because we have FAD previously. Let's go and see the previous one. We found FAD previously, and it is tension. Okay, so we have FAD 40.69. We put it here, and it is tension. It's not compression. So for compression, we're going to change the directions. But since it's tension, use it like this, minus 40.6 times this, so you could find FDC. So FDC is equal 18.5 kilonewton, and it's plus. Our assumption, what was previously? Tension. So this is still going to be tension because the plus. So the answer FDC is equal 18.5 kilonewton tension. Now, let's find summation of forces of Y equal to 0. FDC, remember, sine 18.924, positive. FDB and FDA, sine 36.869. That's it. We don't add 50-50 to the next axis. So this is sine. This is, we don't make sine or anything. FDA, sine 36.869. All positive. And remember, we have FDA. Okay, now we could find, and of course we have FDA and we have FDC. Now we can find FDB. Okay, so we found FDC. Now we could find FDC is known and FAD is known. You could find FDB. So FDB is equal minus 30.4 kilonewton. Now, our assumption is tension, and since it's negative, it's going to be compression. Okay, so FDB is equal 30.4 kilonewton compression. So now, we found AB, AD, we found DP and DC. Now what's remaining? BC. Okay, BC we should take point B, or you should take point C, whatever joint you want to take. I'll take joint B, because BA we have, BC is unknown, and BD we have, and we have 49.5. So if you take joint B, if BA, it's tension, and remember the angle 36.869. If BC is 18.924 and 49.5 down, because you have the reaction, you can see that the force is going down, and 15 kilonewton. Let me see if that's true. No, this is wrong. That's not 15 kilonewton. So it is FBD, no, 140. Oh. Hold on. FBC, FBC, FBA, and 49.5, and BD. What is BD? FBD is 30.4. Summation force at X equal to 0. Let's look what is wrong here. So if you do summation of force at X, you don't do that 15. This 15 is in wrong location. Yeah, you can see that he did not add this in the x-axis. Okay, so there's something wrong with this drawing. Don't worry about this 15. This is wrong. This is wrong. So at B, there is force in the y-axis, and there is the force FBC, and you know the angle here, that's going to be the angle here. The angle here is going to be the angle here. And we have, remember, at point B, one force in the y, one force in this direction, and we know BA, and one force BC, and one force in the y-axis. So the best way is to find summation forces at x equal to 0, because we know this one. So don't worry about 15 is wrong. So if you do summation force at x equal to 0, FBA cosine 36.869 So we'll continue this side of the problem. When you take summation force at x equal to 0, FBC cosine 18.924 minus FBA cosine 36.869, or you just make it the other side to make it plus. And FBC is unknown. If you just do the cosine this, it will be 0.9459. And the FBA, it was given initially. If you go to FBA or FAB, it was given initially. You can see it was 21.9. Remember, it was compression, so we have to put it minus 21.9 because we assume a tension, and we leave a tension all the time. But this time, assume a tension, but give it a minus sign. So we go and put it minus 21.8755 times cosine 36.869. And now FBC is minus 18.5. And remember, we assume a tension, so now it's 18.5 kilonewton compression. That's the end for question number 1, homework number 9.